One of the limiting reactant questions off study guide 3 is if 100 grams of calcium carbonate reacts with 45 grams of iron 3 phosphate, what is the limiting reactant? What is the excess reactant? What is the mass of the iron product? And if 41 grams is actually obtained, what is the percent yield? So I'm going to go ahead and do this problem and then cover like a couple other concepts that aren't on this question. First of all, you must write out the equation. And so when we're looking at a problem like this, it's telling us that we have calcium carbonate. If I can get my pen to work here. There we go. Sorry. Go back. Okay. We have calcium carbonate reacts with iron 3 phosphate, which is FePO4. Now, the thing is I know these charges. That's why I was able to write out those equations or those formulas without looking anything up. Unless you have those formulas memorized, you're not going to be able to do that. Calcium is a positive 2, CO3 is a negative 2, so that's why it comes together as CaCO3. In this case, iron is a 3, phosphate's a negative 3, so that's why it's FePO4. This is a double displacement reaction, and so iron, Fe, is going to wind up with the carbonate. So on this side, on the product side, I'm going to get Fe2, CO3 in parentheses 3, and then the calcium is going to be a 3, and PO4 is a 2. So remember, you have to look up the formula or the charges every time you write a formula. You can't just put them together. So I wanted to point that out because it looked like I was just putting them together, but I also knew what the charges were before I did it. So now we're going to go ahead and balance this. So I have 3 CAs, put a 3 there, that gives me 3 CAs. That gives me 3 CO3s, 3 CO3s. 2 irons, put a 2, it gives me 2 iron, 2 PO4s, 2 PO4s. We now have a balanced chemical equation. So if we have 100 grams of calcium carbonate and we have 45 grams of this, we're going to take both of them over to one of the products. So question C says, what is the mass of the iron product? So we're going to take them both to grams here. So I'm going to go 100 grams of Ca, and I'm just going to go like that because I'll run out of room. And I have 45 grams of the FePO4. Okay. All right, so up here, I'm going to go grams of the Ca to moles, moles of Ca to moles of the iron product, Fe2. And one more time, moles of Fe2. Stop. Fe2, hang on, my pen's going psycho here. 2 grams of Fe2. Okay, so there's the top one. Down here, we're going to do the same thing. So we're going to go grams from the iron phosphate to moles of the iron phosphate. Go again, moles of iron to moles of the iron carbonate. So this one's Fe2. And then moles of Fe2 to grams of Fe2. Now, typically you would write out the entire thing in terms of you would be writing out your entire formulas, but I'm running out of space, so that's why I'm not going to do that. All right, so we fill in. So 1 mole is the molar mass of this. So this is 40. This is 12. 16 times 3 is 48. So this is going to be 100. Mole to mole. For moles of CaCO3, there's 3 of them. And moles of Fe2CO3, there's 1 and 1. This is going to be 56 times 2, so 112. And then up here, CO3. So you've got 12 off this one, 48, because 16 times 3, so there's 60 total times 3. This is going to be 180, so 292. So let's do this top problem first. If I take 100 times the 292 divided by, on the bottom I have 300. This top one I get 97.3. So 97.3 grams of the Fe2CO3. Okay, down here. So I've got 1 mole. All right, so for this one we have 56 on the iron, 31, and 64 for the oxygen. So 56 plus 31 plus 64 gives me 151. Is that right? That doesn't seem right. Yep, that's right. 151's coming down here. Mole to mole, so moles of the FePO4, there's 2 of them, and there's only 1 of the Fe2CO3, and then this is 1 to 292 because we already solved that on the first problem up top. So I'm going to take 45 times 292 equals, divided by, on the bottom, I've got 151 times 2, and that gives me 43.5 on the bottom. So 43.5 grams of the Fe2CO3. All right, so let's see what we've done. What is the limiting reactant? So this one only produces 43.5. So the limiting reactant is the iron phosphate. Ooh, my pen is causing problems, sorry. All right, so the limiting reactant is the FePO4 because it produced the least amount of product. What is the excess reactant? That's the calcium carbonate because he produced more. Now, this can't happen, so we're not going to worry about it. It can't happen because that's if all of that calcium reacted. Not all of it reacted. All we got was 43.5 grams of this. So what is the mass? It's that 43.5 grams because we can only be as good as our least amount. The last question then is, what if 41 was actually obtained? You're going to take your actual divided by your theoretical, which was the 43.5, and then multiply by 100. So 41 divided by 43.5 equals, multiply that by 100, I get 94.3% for my percent yield. All right, if we look down here at the bottom, you notice the answers were already here. So limiting reactant is iron 3-phosphate, yes. Calcium carbonate was the excess, yes. 43.5 grams of iron product is your theoretical yield, and 94.3% was the percent yield. So all of that is right. Now, the last thing then that I could do would be ask you how much is left over. Okay, so how much of the excess was left over. It was not asked on this problem, but I'm going to go ahead and do it anyway. So if I want to know how much excess remained, we're going to take that 43.5 grams of the iron 2CO3, and we're going to take it over to calcium carbonate because that was the guy that was in excess. So this is going to be grams of the Fe2 and moles of the Fe2. Moles of Fe2 to moles of the calcium carbonate, and then moles of the calcium carbonate to grams of the calcium carbonate. Okay, we know this one was 100 because we did it on the problem before. The Fe2, this was 292. And then moles. So there's 1 Fe2CO3 because that comes from right here, and there's 3 of the calcium carbonates. So let's multiply everything on top. So 43.5 times the 3 times 100 divided by 292 tells me that 44.7 grams, 44.7 grams was used. That's a 4. Okay? This is how much was used of the calcium carbonate. If I started with 100, I'm going to take the 100 minus the 44.7 to see how much was left over. So I take 100 minus 44.7, and it tells me that 55.3 grams is left over. So 55.3 grams of calcium carbonate left over. All right, now, like I said, this question didn't ask that, but you will have questions that do ask that. So once again, if you're trying to figure out how much is left over, you're going to go from the limiting product back to the reactant that was in excess, figure out how many grams of excess was used. Okay, so this was my limiting product. I take it back over to the guy that was in excess, the calcium carbonate. It tells me 44.7 grams of calcium carbonate was used. If I started with 100 grams and I only used 44.7, I subtract the 2, and it tells me that 55.3